Alright, we're looking for places of horizontal and vertical tangency. So, vertical lines of tangency will look like this, and we should know that that occurs when dx dt is 0. Horizontal lines of tangency, on the other hand, occur at places like this, and we should know that they occur when dy dt is 0. So let's find dx dt, set it equal to 0, and solve. Similarly, we'll do this for dy dt. For dx dt, we know how to take the derivative of cosine. For this expression, remember, you'll need to use the product rule. And the same thing for this expression. Here we go, dx dt. We end up with this, which simplifies because negative sine of theta and sine of theta is 0. So we're left with just theta cosine of theta is 0, which is true when theta is 0, but it's also true when cosine of theta is equal to 0. So we have these three potential values where there might be vertical lines of tangency. Remember though, if both dx dt is 0 and dy dt is equal to 0 at the same place, then we can't really say there's a point of tangency there. So we'll also need to check dy dt before we can make any conclusions about any of these values for vertical lines of tangency. When is dy dt equal to 0? So dy dt will be cosine of theta minus, and then 1 cosine of theta, and then a negative sine of theta theta. So we're subtracting that, makes it a positive theta sine of theta. Like before, these terms cancel out, and we get theta times sine of theta is 0, so one of these factors has to be 0. It might be that one, or it might be sine of theta. And when is sine of theta equal to 0? When theta is equal to 0 or pi, or 2 pi. So, what have we got here? We can't say that we have a vertical line of tangency or horizontal line of tangency when theta is 0, because they can't both be simultaneously 0. Remember that. If both dx dt and dy dt are 0 simultaneously, then all bets are off. We don't know what's happening. So we're going to have to call off theta equals 0. Notice when theta is equal to 0, x is 1 and y is 0, and at 1, 0, clearly at that point, 1, 0, there's no line of tangency that's horizontal or vertical. Alright, so we'll check pi over 2. So dx dt is 0 at pi over 2, dy dt is not. So we've got ourselves our first vertical line of tangency. What about at 3 pi over 2? They're not both 0 at 3 pi over 2. We have another line of tangency that's vertical. Oops. There we go. What about for horizontal lines of tangency? When theta is 0, nope, dx dt is 0 at the same time, so we're going to rule that one out. So what about when theta is pi? Yeah, they won't be both 0 at the same time there. So we've got our first horizontal line of tangency. And when theta is 2 pi, we will have ourselves another horizontal line of tangency. Why? Because dy dt is 0 there, but dx dt is not equal to 0 at 2 pi. Alright, well, we've got 2 vertical ones and 2 horizontal ones. We're done with the horizontal ones, but we don't have our third vertical one. So let's keep going here. What's the next angle when the cosine ratio is equal to 0? We knew that pi over 2, and then 3 pi over 2, and then 5 pi over 2. So in this picture, in the portion of the curve shown, we're going to have 3 vertical lines of tangent and 2 horizontal lines of tangent. Now it actually asks for the points, so we're going to have to go ahead and find these points. So just by plugging in these values into these expressions, we get our x and y coordinates. see that this is A, this is B here, and C is right there. And plugging in pi and 2 pi into x and y, we get points D, which is there, and E, which is where we have our horizontal lines of tangency. All right, that's how you do number 27.